Okay, here are the notes for electrostatics part 2. Electrons move easily in good conductors and poorly in good insulators. Outer electrons of atoms in a metal are not anchored to the nuclei of particular atoms, but are free to roam in the material. Materials through which electric charge can flow are called conductors, so the electrons can move about very easily. Metals are good conductors for the motion of electric charge because the electrons are very loose in metals. Electrons in other materials, rubber and glass for example, are tightly bound and remain with particular atoms. They are not free to wander about to other atoms in the material. These materials, known as insulators, are very poor conductors of electricity. A substance is classified as a conductor or an insulator based on how tightly the atoms of the substance hold their electrons. The conductivity of a metal can be more than a million trillion times greater than the conductivity of an insulator, such as glass. In power lines, charge flows much more easily than through hundreds of kilometers of metal wire than through the few centimeters of insulated material that separate the wires from the supporting towers. Semiconductors are materials that can be made to behave sometimes as an insulator and sometimes as a conductor. Atoms in a semiconductor hold their electrons until given small energy boosts. This occurs in photovoltaic cells that convert solar energy into electrical energy. Thin layers of semiconducting materials sandwiched together make up transistors. What is the difference between a good conductor and a good insulator? Two ways electric charge can be transferred are by friction and by contact. We can stroke a cat's fur and hear the crackling of sparks that are produced. We can comb our hair in front of a mirror in a dark room and see, as well as hear, the sparks of electricity. We can scuff our shoes across a rug and feel the tingle as we reach for the doorknob. Electrons are being transferred by friction when one material rubs against another. If you slide across a seat in an automobile, you're in danger of being charged by friction. Electrons can also be transferred from one material to another by simply touching. When a charged rod is placed in contact with a neutral object, some charge will transfer to the neutral object. This method of charging is called charging by contact. If the object is a good conductor, the charge will spread to all parts of its surface because like charges repel each other. What are two ways electric charge can be transferred? If a charged particle is brought near a conducting surface, even without physical contact, electrons will move in the conducting surface. Charging by induction can be illustrated using two insulated metal spheres. Uncharged insulated metal spheres touching each other, in effect, form a single non-charged conductor. Alright, when a negatively charged rod is held near one sphere, electrons in the metal are repelled by the rod. Excessive negative charge has moved to the other sphere, leaving the first sphere with an excessive positive charge. The charge on the spheres has been redistributed or induced. When the spheres are separated and the rod removed, the spheres are charged equally and oppositely. They have been charged by induction, which is the charging of an object without direct contact. Charge induction by grounding can be illustrated using a metal sphere hanging from a conducting string. A charge redistribution is induced by the presence of the charged rod. The net charge on the sphere is still zero. Touching the sphere removes the electrons by contact and the sphere is left positively charged. The positively charged sphere is attracted to the negative rod. When the electrons move onto the sphere from the rod, it becomes negatively charged by contact. When we touch the metal surface with a finger, charges that repel each other have a conducting path to practically infinite reservoir of electric charge, the ground. When we allow charges to move off or onto a conductor by touching it, we are grounding it. Charging by induction occurs during thunderstorms. The negatively charged bottoms of clouds induce a positive charge on the surface of the earth below. Most lightning is an electric discharge between oppositely charged parts of the clouds. The kind of lightning we are most familiar with is the electrical discharge between the clouds and the oppositely charged ground below. If a rod is placed above a building and connected to the ground, the point of the rod collects electrons from the air. This prevents a buildup of positive charges by induction. The primary purpose of the lightning rod is to prevent a lightning discharge from occurring. If lightning does strike, it may be attracted to the rod and short circuit to the ground, sparing the building. Why does the negative rod in the two spheres example have the same charge before and after the spheres are charged, but not when charging is taking place in the single sphere example? In the first charging process, no contact was made between the negative rod and either of the spheres. In the second charging process, however, the rod touched the sphere when it was positively charged. A transfer of charge by contact reduced the negative charge in the rod. What happens when a charged object is placed near a conducting surface? Charge polarization can occur in insulators that are near a charged object. Charging by induction is not restricted to conductors. Charge polarization can occur in insulators that are near a charged object. When a charged rod is brought near an insulator, there are no free electrons to migrate throughout the insulated material. Instead, there is a rearrangement of the positions of charge within the atom and molecules themselves. One side of the atom or molecule is induced to be slightly more positive or negative than the other side. The atom or molecule is said to be electrically polarized. When an external negative charge is brought closer from the left, the charge within a neutral atom or molecule rearranges. All the atoms or molecules near the surface of the insulator become electrically polarized. Polarization explains why electrically neutral bits of paper are attracted to charged objects, such as charged comb. Molecules are polarized in the paper, with the oppositely charged sides of the molecules closest to the charged object. The bits of paper experience a net attraction. Sometimes they will cling to the charged objects and suddenly fly off. Charging by contact has occurred. The paper bits have acquired the same sign of charge as the charged object and then are repelled. A charged comb attracts an uncharged piece of paper because the force of attraction for the closer charge is greater than the force of repulsion for the further charge. Rub an inflated balloon on your hair and it becomes charged. Place the balloon against the wall and it sticks. The charge on the balloon induces an opposite surface charge on the wall. The charge on the balloon is slightly closer to the opposite induced charge than the charge of the same side. If you see right here, these positive and negative charges are very close together, so they're going to attract each other, whereas these want to repel the balloon, but they're further away. They are greater distance away, so that's why it attracts one another. Many molecules, such as water, H2O, for example, are electrically polarized in their normal states. The distribution of electric charge is not perfectly even. There is a little more negative charge on one side of the molecule than the other. Such molecules are said to be electric dipoles. Here it is, be glad that the water is an electric dipole. If its opposite ends didn't attract different ions, almost all the chemistry that occurs in aqueous solutions would be impossible. In summary, objects are electrically charged in three ways. By friction, when electrons are transferred by friction from one object to another. By contact, when electrons are transferred from one object to another by direct contact without rubbing. And by induction, when electrons are caused to gather or disperse by the presence of nearby charge without physical contact. If the object is an insulator, on the other hand, then the realignment of charge rather than a migration of charge occurs. This is called charging by polarization, in which the surface near the charged object becomes oppositely charged. What happens when an insulator is in the presence of a charged object? That's the end of the notes.